If you stop and think about it, our entire world runs on a kind of invisible, high-speed choreography. From the robotic arms that build your car to the bottling plants that fill your drinks, there's a hidden brain behind the scenes, tirelessly making decisions.
So what is it? What's the mastermind conducting this incredible industrial symphony second by second without ever missing a beat?
Well, the answer might surprise you. It's not some giant, fragile supercomputer locked away in a clean room. Nope, it's this tough, reliable, unassuming little box called a Programmable Logic Controller, or PLC for short. This is the real unsung hero of all things automation. And today we're going to pull back the curtain and see exactly how this hidden brain works.
So let's start there. To really get it, you have to understand just how central the PLC is. It is, quite literally, the factory's brain. And what's really incredible is just how scalable they are. A single PLC can start off small, but with these simple plug-in modules, it can expand to control thousands of different devices. We're talking over 8,000 inputs and outputs for a high-end system. That's like one single brain commanding an entire army of machines.
All right, so how do we wrap our heads around this? Well, the absolute best way to understand a PLC is to think of it just like a person. It has senses to see what's going on, a brain to make decisions, and muscles to actually do things.
And at its core, a PLC has three parts that line up perfectly with that analogy. You've got the input modules, those are the senses. You've got the central processor, that's the brain, and you've got the output modules. Yep, those are the muscles. So let's break each one down.
First up, the inputs. These are the PLC's eyes, its ears, its sense of touch. They take all the signals from the various devices out on the factory floor and translate them into a language that the brain, the processor, can actually understand.
So what kind of senses are we talking about? Well, they can be super simple, like an operator pushing a button or a little switch that clicks when a box moves into the right spot. But they can also be way more complex, like a temperature sensor making sure a liquid is just right, or a pressure sensor that keeps the tank from getting dangerous.
Next, of course, is the processor, the CPU. This is the brain of the whole operation. It takes all that information coming in from the senses and it checks it against a program, basically a set of rules we gave it, and then it decides exactly what needs to happen next.
And finally, you have the muscles, the output modules. The brain makes the call, and the outputs are what carry out the command. They send the signals that make things physically happen. Turning on motors, opening up valves, sounding alarms, all that good stuff.
This is where the rubber meets the road. The PLC might tell a motor starter to get a conveyor belt moving, or tell a solenoid to open a valve and let liquid flow, or tell a big horn to go off. This is the moment a digital decision becomes a real, physical action.
Okay, so we've got the senses, the brain, and the muscles. But how do they all work together so seamlessly? It all happens in this ridiculously fast, continuous loop called the scan cycle.
The scan cycle is basically a two-step dance that repeats over and over and over. First, the PLC scans all of its inputs, getting a complete snapshot of what's happening in the world right now. At the same time, it updates all the outputs based on the decision it made in the last cycle. Then, step 2, it takes that brand new snapshot of the world and runs it through the program logic to figure out what it's going to do on the next loop.
And how fast does all that happen? How long does that two-step cycle take? It's mind-bogglingly fast. A typical scan is just 5 to 20 milliseconds. To put that in perspective, a PLC can read all its senses, think about it, and command all its muscles up to 200 times every single second. It's insane. So how do you even tell this brain what to do? You might be thinking you need to be some sort of coding wizard, right? Nope. Instead, PLCs use this brilliantly simple and visual language.
This picture just says it all. On the left, you've got this spaghetti mess of a traditional electrical diagram. Good luck trying to figure that out in a hurry. But on the right, that's the exact same logic, just written out in something called ladder logic. It's clean, it's organized, it's intuitive. This was an absolute game changer for technicians on the factory floor.
The whole concept is based on the rungs of a ladder. You can see it, right? Each rung is just one single rule, one instruction. You read it from left to right, and the logic is always the same. If the conditions on the left side are true, then the action on the right side happens. It's really that simple.
And even the fundamental building blocks of programming become totally visual. Let's say you need an AND condition, where thing A and thing B have to be true. You just put two switch symbols in a series. Need an OR condition, where A or B can be true?
You just put them in parallel. It's almost like building a flowchart with simple electrical symbols. Okay, time to put it all together. We've got the senses, the brain, the muscles, and this cool ladder language. Let's walk through a real-world example and see how a PLC would control a simple jar filling system. So, first off, the PLC has to manage the main tank of liquid. It's using its senses, a temperature sensor, a couple of level sensors, to check the conditions. Based on what those senses are telling it, its brain, the logic, decides when to command its muscles, in this case, solenoid valves, to open up and let more liquid in. And this is where the logic is just so powerful. For safety, check out this one rule here. It tells the heater that it can only turn on if two things are true. The liquid level isn't too low, and the temperature isn't already too high. It's just a simple instruction that prevents an accident before it can even think about happening.
And finally, the main event, filling the jars. A position sensor tells the PLC, hey, a jar is in place. The brain checks if all the tank conditions are good, and if they are, it opens the filling valve. As soon as another sensor detects the jar is full, the brain immediately closes the valve and tells the conveyor motor to bring in the next one. Sense, think, act. It's a perfect, repeatable little dance.
And that right there is the magic of the PLC. You've got sensors gathering information, a brain making decisions based on that simple ladder logic, and muscles carrying out those decisions with perfect precision. All of it happening in a constant loop, faster than you can even blink.
So, the next time you see a traffic light change, or you ride in an elevator, or watch any kind of factory line moving, remember that hidden brain at work. Now that you know its secret, how it senses, thinks, and acts, what parts of our automated world are you going to see in a whole new light?